In this part of the assignment 2B about visualization and map display, we will show some of the basic data display operations that we will need in our modeling assignments. After you open GRASS, you should have assignment 2 in bold, shown as current from the previous assignment 2A. You can also create a new map set if you wish and call it assignment 2B, for example, by right-clicking on your project and selecting create map set. But I will be working in my assignment 2 map set. Now, let us also change our working directory to our working directory where we will save the images for our report and we will put any external files that we may need. So we will select console here, CD, enter, and I under documents, GIS 582 report, I will select homework 2 directory as my working directory where I will be putting all the output maps and where I also have one text file prepared for this assignment. Now, in this assignment, we will be generating some outputs with text for legends and map titles. So we can also change the font, default font, if we don't like it, to something better. So we can go to Preferences for Map Display by clicking on this icon. And then under, let's stretch it so that we can read it better. Under Map Display, you can select and set font for the GRASS displays. And this is a default font that will be used when you are working with GRASS. So I will select Arial Regular. And this will replace the font that's come originally with GRASS. Now, in the assignment instructions, we start with visualization in 3D perspective. There will be different videos that cover the visualization and that replace the old visualizations 1, 2, 3 that were done with GRASS 6.4. So let's skip this part and let's go straight to basic two-dimensional display operations. So in the first part, we will be displaying subset of raster data along with shaded elevation and then along with the color composite. So we can do this again using the graphical user interface or using the command line. So first, let's set region to the raster that we will be displaying, and that will be the land use map from 1996. And let's now add elevation shade layer to the map layer. So we can do it through the graphical user interface here. And then we will add land use map from 1996. Again, we can do it through this interface. But now, instead of displaying all the categories in this land use map, we will select only category 1 and 2, which represents developed areas. So let's first add the entire map, and then we can double click on it and do a selection, and we will select just categories 1 and 2. And now we can also change the opacity to make it a little bit transparent so that we can see the shaded topography below this map layer. And with this combination of shaded elevation and the developed areas, we can visually assess what is the topography, what is the complexity of topography in the developed areas and outside the developed areas. And you can see that most of these developed areas are in flat, in areas with flat topography or on some hill slopes. So we can then add also streets map just for the context, and we will see how the streets look like for the in those areas that are developed. So you can see that they are much denser, but we can also see a lot of streets in this street layer in those areas that are not mapped as developed. And you can think about like why this is, given that the developed layer is from 1996. So let's save this layer for your report. And we are, of course, curious about the land use development in this area that might have happened later on, because this is quite a few years ago. And we can do just a simple visual comparison with the Landsat data that we have in our data set. However, our Landsat data are provided in channels. So we can now combine the red, green, and blue channel to create a composite map with natural colors and compare those with our land use data layer. So let's just add this RGB composite, and I will do it with the command line. Sorry. And let's just put the land use on top of this map, on top of our set of layers. And let's change its opacity. And now you can see, you can visually compare the spatial pattern of developed areas that we have in the NLCD, in the USGS classified land cover map from 1996, with the pattern of developed areas that are that you can infer from the Landsat imagery. And let's put the streets on top. And I will change their color. So now you can see that there is indeed some development in these areas where we have lots of trees. And in our assignment instructions, we display only the major roads. So let's just switch off the streets so that the map is not too busy, and we will just display the major roads. And again, let's save this image to our directory with the outputs for our report. And don't forget to answer the question, how did the development area change between 1996 and 2002 based on your observations of these data layers? Now let's look at the ways how we can change the color tables or the color ramps for our maps. So I will erase the layer manager, and let's create a copy of our elevation map. So we can actually do it through the data catalog, but we can also do it here. So we now have our own copy of the raster map elevation, and we will use it to explore different ways how we can change the color tables in raster maps. So you can right click on that layer and set color table, and under define you can set it, for example, to elevation. And let's see whether that's a different color table than what is used in the provided data layer. So it is very similar, but we get rid of those dark brown layers. And if you wish, you can add a legend, but we will cover legends later on. I will add it here. And to avoid having the legend displayed in the image, we can right click on it and select resize and move legend, and we can then move the legend horizontally here, which can create a nicer output. And we can also add a scale bar there. And you can just move them with your mouse. Let me make this a little smaller. Okay, and we can save this to for our report. Now, this change was really using an existing predefined color table. But there are some outputs that we will be generating, for example, flow accumulation, soil erosion, erosion and deposition, which have very nonlinear distributions. and where we need to highlight just certain intervals of the values. And for that, it is useful to generate custom color tables. And to create these custom color tables, we can predefine the colors in a text file. And here is an example how it can look like. Instead of explicit names for the colors, you can also use RGB definitions, assign them not just to the values, but also the percent values, many other options. Please see the r.colors tool manual page for more information about this. But I already put these colors into a text file, my color txt, and I saved that text file in the in my current working directory. So I can now copy this file and set the color table for this raster map using this predefined set. You can also do it in such a way that you can set color table through the graphical user interface. And here you have input file. No, under definitions, you have paths to rule file, or you can enter values directly. So you can just copy paste these values here. Or path to rules file would be you can browse to this directory, and here I have that my color txt file, and you can use it, do it entirely through graphical user interface. But of course, the command is faster. And now we can again save this map with its new legend for our report. Now let's compare. So this was very simple color ramps, just with equal intervals, because our elevations are relatively homogeneously distributed in this area. Now let's look at the slope map. And we will explore the impact of different slope maps of the pattern of slope that we can display when we select different color distributions. And I will do this part in command line because it's essentially very similar to what I have shown you in the graphical user interface. So I will create a copy of the slope map. Then I will assign the slope map a predefined color ramp, which is called blue, green, yellow, red. And when you open the manual page, you will see how that map looks like. And then the slope map with this color ramp is now added to the display, and we also want to change the legend. Oh, it actually changed. We just have you can see that there it goes all the way through the red, but we don't really see much red in this image. We can zoom in and see that there are indeed some steep slopes in this area. For example, these are Swift Creek Bluffs. Let's go back to our region, computational region. But as you can see, most of this area is in the blue and green range. That means way below the 15 degrees slope. So now what we can do, we can use the same color table, but we can make it histogram equalized. That means that the colors now will be assigned not based on the distributed, not based just on the value, but based on the how much area each value actually covers. So let's see how it will look like. So let's first save this this map. Okay. And as you can see, now the values are distributed more evenly in terms of area. So we are getting much better representation of the structure of the slope, but the quantitative representation in terms of how much of, let's say, the low slopes or high slopes we have is now distorted. And you can see that on the legend, how these values are distributed. So let's save this map again for our report. And then let's look at the histogram for the slope map. And let's just click here. And this is better to do through graphical user interface so that the histogram is displayed in a separate window. So I will select, there are two options for create histogram. I will select create histogram with the histogram. And here it is. And I need to change the font here to actually show the text. So you can see that most of the values are indeed between 0 and 6 degrees. So let's save this as well for your report, and then you should comment on what you actually can understand about slope distribution when you display with the regular interval ramp and when you display slope map with the histogram equalized color ramp. So this is our histogram. Okay, we can quit it. Now, you have seen me modifying already the legend. So you just right click on it and you can move it and resize it. You can, for scripting purposes, you can also define the legend location using the position in terms of percentages of the display. So for example, I can display the legend here using this command. So it will be displayed vertically, and then you can just move it with your mouse. And I will remove this one. Or here is the horizontally placed legend. So Here are the numbers. And please read the manual page to explain how this number to properly interpret the numbers. So do you see this is where you want it in this location. Then the bar scale, we already have used bar scale quite a few times. Here is again, you can use a command line to select certain specific location for the bar scale and to select its specific length. Here we have it as 1,000 meters. I have used 5 kilometers. That's the default. And now the last thing that we will look at here is the grid. Very often, for reference, you want to include a grid into your map. So let's just do it again, like using command line, and we will display the XY grid in coordinates of the projected coordinate system, and then we will also display the latitude longitude grid. So let's just do my elevation. And again, I need to change my font here. And so that's a legend. And then let's add the grid. With ticks. And then we can add more detailed ticks. So this will be just without the text, but there is also an option to add a text to it with the actual coordinates. I probably again have the wrong font. So you should see also the actual coordinates if you don't change the fonts. So let's just output this, and we can switch off these grids and just add the latitude longitude grid. And again, it should have also the numbers. And you can see that there are many options for what to actually display and what not to display. Color. You can just do marks instead of grid lines. And finally, you can also explore the map swipe. So for map swipe, I need the maps, the ortho maps. I would like to compare now the maps in the the orthophotos that we have imported from WMS with the old orthophoto. And I have those orthophotos in the assignment 1 map set. So let's just add that assignment 1 map set to make it accessible. And I will then open the map swipe. And I don't need this one. I will need the orthophoto from here. And the second map will be from assignment 1. And now, because I saved it as a small map, I will zoom into this area. And now I can use map swipe to compare how this area has changed. So you can see that there are some experimental plots in this area. Something was built also here that was not there previously. And again, you can pick up a location and then just save an image for your report. Okay, so that is all for this part on map display.